All right, hello there, geometry friends. We are on lesson 3 of chapter 8, 8.3, solving triangles. We're going to really begin to continue to apply our SOHCAHTOA, our sine, cosine, and trig ratios. And we're going to be solving triangles. And this is kind of the heart and soul, or the meat and potatoes of trigonometry. So very important, very foundational, and something you want to get very comfortable with. So here we go. We only have one definition, and that is this thing called an inverse trig function. So an inverse trig function, we have the basic definition there. It's a trig function used to solve a missing angle. So that's the key thing. You're missing the angle, and you find that missing angle using a ratio of the sides. So in other words, you're going to use an inverse trig function when you know the sides, but you don't know the angle. Okay, so this is what it would look like. So say you have, we'll just use sine as an example. You have sine of some angle, we'll just call it angle A. But then you actually know what you have a ratio of a two sides. In fact, let me draw a triangle. So we have this nice little right triangle here, and I've got angle A there. This would be angle B and C. But I'm trying to find angle A here in the bottom right. And say I know that this side of the triangle is 3 and this side of the triangle is 5. Okay, so that means I can make the trig ratio. Well, we'll just go ahead and put this one as 4. Okay, and so we're going to use sine. SOHCAHTOA. So, if you remember from our last lesson, is opposite over hypotenuse. So that means I would set this up with the opposite side, which in this case would be 3, over the hypotenuse, which is the longest side there, as 5. So we can say sine of A equals 3 over 5. So this is what I mean where you know the side ratio. I know the ratio of the sides. In this case, because it's sine, it's opposite over hypotenuse. And now what I want to do is I want to find this angle right here. I don't know angle A. So what angle is equal to sides 3 over 5? This is where our inverse trig function comes into play. And this is what it looks like. It's written as, so the inverse trig function of sine is simply inverse sine. And the way they write that is with a little -1 to the top. Okay, in fact, maybe I won't write that slanted, I'll write it straight on top of it. But sine -1. Okay, and so that means what that implies is that I'm going to input that sine of -1 of 3/5 is going to give me my missing angle. And so you'll see, I'll pull up my calculator. Let's get her going here. You'll need the scientific function so that you can do sine and cosine. But you can see your calculator usually has the sine, cosine. Oh, I already have it set. You have the sine. Sorry, no, it's a little hard to see. You're doing this. You have sine, cosine, and tangent right there. But if I hit shift or this little arrow key, now all of a sudden look at sine, cosine, and tangent. They have the little -1s on top of them. That means I'm ready to use inverse sine. So if I hit inverse sine and I do 3 divided by 5, because that was my ratio, notice it puts it up as this thing called a sine. But if I hit equals, you can see I actually get a degree. It's with a decimal, but I'll round it, 36.9 degrees. That means that this angle right here, angle A, is 36.9 degrees. Okay, and the way what I can show you is if you reverse it, if I take the sine of 36.9, if I put it in and I don't do the inverse sine, but I just use sine of 36.9 and I hit equal, then I get 0.6. Well, what's 0.6? 0.6 is 3 divided by 5. So it just simply takes me back to where I started. So what inverse trig functions allow you to do is to take the side ratios of a triangle and then solve for the missing angle measurement. So your answer will always come out of an inverse trig function as, excuse me, boys, got friends here with me making the video. Okay, it will allow you to find the missing degrees. Okay, another way to think about inverse trig ratios is like it's the opposite function. When you add, the opposite of adding is subtracting. Like, how do you undo addition? You subtract. How do you undo multiplication? You divide. How do you undo squaring? You square root. So how do you undo sine? You use inverse sine. And again, I've written inverse sine, but you have the same three. You also have inverse cosine, and you also have inverse tangent, depending on which trig ratio you're using in a particular case. But the key thing to remember is what you use these for right here, and I'll include sine as well, is you're always using these to find the angle. Okay, whereas when you use regular sine, cosine, and tangent, if you select that, you're actually calculating it from an angle to find the ratio. Okay, well, let's do some examples to clarify that. We got some questions here. The first question is, what feature on your calculator will you have to use to solve for angles using trig ratios? Okay, this is just a setup, but these three scenarios that I've written right here are the three examples of when you're going to use the inverse trig ratio. So here again, notice what all these three have in common is I know the ratio of the sides. And what do I not know? I don't know. I'm missing the angle measurement in all three. So this is where I'm going to either use inverse sine, inverse cosine, or inverse tangent. And so the question says, what feature on your calculator will you use to solve for the angle? You're going to use the feature, the inverse trig function. On some of your calculators, depending on which kind you use, this inverse trig function it'll either look like something like that, or it might even look like something like this, arc. Sometimes they write it as arc sine. If your calculator shows you arc sine, that's the same thing as a sine to the -1. And it's not to the -1, it just means inverse sine function. So how would I solve all these three examples? Well, that's just what I would do. I would go ahead and do inverse sine of 1/2. And that will give me A. Or I'll do inverse cosine of 3/5, and that'll give me B. Or here I would use inverse tangent of 0.6854. Notice you can do this with decimals too, because we're used to seeing ratios as fractions, but fractions and decimals are the same thing. They're just written in different forms. So in all these three cases, I can simply do it. I'll calculate each one. So shift, inverse sine. Again, I make sure I'm using the sine. Oops, there we go. Oh, weird, sorry. Use the sine button with a -1 on top. Okay, and then I just write in 0.5. Okay, unless your calculator takes fractions. So we've got inverse sine of 0.5. Again, mine says a sine. Then I hit equals 30, because the inverse sine of 1/2 is exactly 30 degrees. So in this case, we get 30 degrees. And that makes sense. Okay, I mean, that's a reasonable measurement for an angle. Okay, then I can do the same thing. I can do inverse cosine of 3 divided by 5. Whoops, that's what we just did in the last problem. Or not quite. So there's inverse cosine of 3 divided by 5, or 3/5. If I hit equals, I get another reasonable angle measurement, 53.1. So that's 53.1 degrees. These are just examples I made up. But then I can do the same thing with a tangent. Inverse tangent of 0.6854. So you can input a decimal in there just like you would input a fraction. And I hit equals, and I get a reasonable angle measurement, 34.4. I say reasonable because I'm not getting some tiny decimal like 0.0678. That's not a very reasonable degree. I'm not getting also something like 20,000 or 4,000. You can have 4,000 degrees, but you're not going to have a triangle with an angle of more than 180 degrees, 179 degrees, even 178 degrees. So there, anyway, this last one was 34.4. Sorry, that's a little sloppy. 34.4 degrees. Okay, so that's when you're going to use your trig inverse button to find missing angles when you already know the ratio, or you already know the sides together. Let's look at our second question. Our second question says, what do you use sine, cosine, and tangent for, and when do you use inverse sine, inverse cosine, inverse tangent? This is a really basic question, but we've said it several times. You use the first set when you know the degrees, or you know the angle. When you know the angle, you're going to plug that into sine, cosine, and tangent. You're going to use the inverse ones when you know what? Yes, I can hear you in your head thinking it. When you know the side ratio, which will either look like a fraction or like some kind of a decimal. Okay, because these ones are they going to tell you the first set, sine, cosine, and tangent, they're going to tell you what the sine ratio is. Hello, Ethan. Thank you. Excuse me. Okay, and the inverse tangent are going to tell you the missing angles. Okay, so you want to get kind of clear on that, the purpose of each one. And now we just have a couple questions straight from the textbook. We're looking at number 4, page 537. Number 4, it gives us this triangle of 6 inches, 8 inches, and a hypotenuse of 10 inches. And we are supposed to figure out which angle would give us a side ratio of 0.8. So we're actually not even finding the angle measurement. We could, but we'd have to consider which angle, 1 or 2. We know it's never going to be this one. The right angle will never be your reference angle in doing a trig problem. So it's only going to be angle 1 or 2. So which one gives me a cosine ratio of 0.8? Well, first, let's remember what cosine is. So, ca, to, so, ca. So, C-A-H. So that means cosine is adjacent over hypotenuse. Okay? So, so the question is, the hypotenuse is definitely 10. So it's either going to be 6 over 10 or 8 over 10. Which of those is equal to 0.8? Well, that's the 8 over 10. So in which angle, 1 or 2, is the adjacent angle 8, and then, of course, the hypotenuse is 10? Well, if I stand here at angle 1, I can see that 6 is closest and 8 is opposite. So that doesn't look right. Whereas if I pick angle 2 as my reference angle, I can see that 8 is adjacent to that. And then, of course, 10 is the hypotenuse. So to get a ratio of 8 over 10 of 0.8, I must be referencing angle number 2. Okay, so this question is just a question. They're just trying to get you used to recognize which reference angle you're using based on the ratio they give you. We could then use inverse cosine function in order to find the measurement, the degrees of angle 2, but this question isn't asking us to do that. We could do that more like on number 8. So number 8 is just getting us used to using our calculator. They've given us an inverse cosine of 1/3. So what we get out of that is going to be some sort of an angle measurement. So this will be real simple. Okay, we just simply make sure we're on inverse cosine, or inverse functions. If you're not, you'll have a shift key that allows you to do that. So I'm going to hit inverse cosine, and I'll do 1 divided by 3. So we've got 1 divided by 3, and I can see below that I'm going to get an answer of 70.5. So our answer, it says to round to the nearest whole degree. So 70.5, that'll actually round to approximately, we should make this approximate, 71 degrees. Okay? And I can verify that because I can see that if I take the regular cosine of 71 degrees, input the degrees, I should get 1 over 3 or 1/3. And if I do that, I get 0.33333. Okay, so the inverse cosine of 1/3 is just 71 degrees, and I just do that using my calculator function. All right, our last problem, and probably the problem most representative of basic solving triangles, is this. They give us a right triangle, and they'll give you 2 pieces of information. In this case, they've told us that we know angle A is 32 degrees, and we know that the hypotenuse here is 7.4. Now, what do they want us to do in number 14? They want us to find all the other angle measurements and all the other sides. Okay, so let's take that step by step. First, let's look at our angles. Angle A, do we know what angle A is? We do, it's 32 degrees. Okay, do we know what angle B is? Well, it's a right angle, so we know that that is 90 degrees. How about angle C? Do we have to do anything fancy in order to find angle C? Well, no, because I know if I can just use my triangle sum rule, I know that angle A and C must add up to 90. So if angle A is 32, then that makes C 58. So I could solve for my missing angle without doing any sort of trig whatsoever. Because I know that those two, A and C, are complementary. They add up to 90 degrees. So now let's look at our side lengths. How about side A, which would be right here, side B, which would be right here, and side C, which is right here. Well, side A, we don't have, but we know side B. That's the one they gave us. They gave us side B as 7.4. So the bulk of this problem is, how do I find my missing sides? Well, the answer is we're going to set up some trig ratios. Okay, so let's start with side A. So I need to know side A, and I'm going to find it based on what they give me. They give me angle 32. Question is, do I use sine, cosine, or tangent? Well, it always depends on what you have. I'm looking for the opposite of the 32 degrees. So that means I'm not going to use cosine because that's adjacent, but I'm going to use either tangent or sine. But the other number I know is right here, the hypotenuse. So that means I have to use the trig ratio that combines the opposite and the hypotenuse. Well, which one is that? SOHCAHTOA. So that means I'm going to be using sine. That's probably the trickiest part of trig is understanding, okay, how did I decide which one to use? And it was all based on the side you're trying to find, or angle sometimes, and what information they've given you. In this case, based on the angle we know, we're looking for the opposite and hypotenuse, so that's what determined that we would in fact use sine. So let's set it up. We do sine of 32 degrees. The degrees always go next to the sine, cosine, or tangent. And then that equals a fraction, a ratio. Opposite, well, that's the one we don't know. That's A over hypotenuse. And that's the one we do know, 74 or 7.4. So now we have a simple equation here. Sine 32 equals A over 7.4. If you remember from 8.2, we can calculate sine of 32 just by plugging it into our calculator. Sine of 32. And that's going to give us a decimal. It's going to be, this is the one you want to record to 4 decimal places, 0.5299, and that's equal to A over 7.4. Okay, so now how do we get A by itself? Well, let's multiply that 7.4 both sides, because then that will cancel it on the right, and all we'll have left is our A. So what is 0.5299 times 7.4? We get 3 point, says we're rounding to the nearest hundredth. Okay, so when I do that, I get 3.92. So A is equal approximately to 3.92. So that means this side over here is just under 4. We don't know what we're measuring, 4 units. And that makes sense, at least, because the hypotenuse is 7.4, so it's got to be something smaller. So 3.92 makes sense. So now we've got our second side. A is 3.92. So how are we now going to find side C? Okay, we're going to repeat the process, but we're going to use the appropriate trig function. So now I don't want A anymore. I want C. So C, from my reference angle of 32, is adjacent. And again, I still know my hypotenuse. So now I need the trig function that uses adjacent and hypotenuse. SOHCAHTOA. Ka is adjacent over hypotenuse. So that means I'm going to do, because here we go, adjacent hypotenuse. And so that means I'm going to use cosine. Okay, so let's set it up just like the last one. Cosine of 32 equals, in this case, C over 7.4, because that's my hypotenuse. And we're going to solve it in the exact same way we just solved the last one. We can figure out what cosine of 32 is. I'm going to put that in my calculator. Cosine of 32 is 0.8480. And that equals C over 7.4. Now, how do I get C by itself? Just like last time, I'm going to multiply by 7.4 on both sides. Cancels here on the right. And so we get times 7.4. And so I get 6.28 if I round. 6.28. 6.28 equals approximately C. And again, that answer makes sense because that leg of the triangle even looks longer than A, but it's still less than the hypotenuse. So 6.28 seems like a reasonable answer. So now I have officially solved the triangle. When we say solving a triangle, what that means is you find all three angles and all three sides. The angle was very easy because we just did the triangle sum theorem, but then we used our trig ratios to find side A and C. Again, probably totally new process to you, just like a 7.1 was a little overwhelming for you. But I promise you, we're going to drill and kill this, and you're going to get very good at it because it's very useful, and it will be a reoccurring skill that you'll need again and again, both in this class and in the future. So if you want to rewatch that part, go ahead. We'll be discussing this in class, and I look forward to it. All right, see you soon.